Hey y'all, and welcome back. Today we're going to be talking about representing data using stem and leaf plots. Now I'll tell you that stem and leaf plots are my personal least favorite because I don't think they're as good as some of the other methods that we have, and they really often confuse lots of my students. Let's look at how a stem and leaf plot works. A stem and leaf plot helps us to get an idea of the shape of the data. So what we do is we focus in on this first digit here, and everything to the left of it is going to become our stem. So I'm going to look here and I'm going to see what kind of stems I see. I see 6s in the tens place, I see 7s in the tens place, I even see a 5 in the tens place, an 8 in the tens place, and a 9 in the tens place. That's a lot of stems. So I'm going to draw out my stem and leaf plot like this. Here I've got my stems, and over here I have my leaves. First, I'm going to put those stems in order from least to greatest. I see a 5, then a 6, then a 7, an 8, and a 9. So I'm going to put the stems over here. 5, 6, 7, 8, and 9. That's my stem and leaf plot. Now I need to put in those leaves. So first, I'm going to look at everything that has a stem of 5. So everything that has a 5 in its tens place. This is the only one that has a 5 in its tens place, and it has a 3 in the ones place. So my leaf is 3. We can read this as 5 and then a 3, or 53. Now let's look at 6. When I look at the 6s, I see a lot of those stems. We used up the 53, so I can scratch that one out. But for the 6s, I see 60, I see 67, 65, 67, 67, 62, and 69. We have quite a lot of 6s. We're going to have to fit a lot of leaves on here. Again, all we do is we put them in order. The first one that would come would be a 60, because 60 is the least number. So I put a 0 here. And then, without doing anything else, I put the next number in there. 60, my next thing I see is 62. So I'm going to put a 2 in here. Remember, this isn't 602. These are two separate numbers, 60 and 62. Then I see, after I've gotten rid of this 62, I see a 65. So I'm going to write a 5 here on my leaf, with a stem of 6 and a leaf of 5. Now I see 1, 2, 3 things that are 67. So I'm going to write in on my stem of 6, 1, 2, 3 sevens. Finally, I see a 69. So I'm going to put a 9 here for 6, 9, 69. Then I'm going to do the same thing with my 70s. For my 70s, I see a 72, a 76, and a 78. I'll go to my stem of 7, and I'm going to put those in order. 72, 76, 78. Remember, this is not one big number. Each time I have a leaf is a separate number. I take the stem with each leaf. 72, 76, 78. So all of my 70s are done now. Now I've got to do my 80s. I see an 80, an 81, and an 82. And then my 90s, I see a 97. This helps us to get an idea of the shape of the data. We can see that not very many people got in the 50s, but lots of people got into the 60s. So we can get an idea of what the shape of the data is. It helps us to see, in general, where is everything. Let me show you one more thing that can sometimes get complicated. Right now, we just looked at 2-digit numbers, where we have just the tens digit and the ones digit. What if I had 3-digit numbers? What if I wanted to place into a stem and leaf plot 123? Or what if I wanted to use some decimals? I wanted to do 2.35. We can actually do these pretty simply. We still only focus on this last bit On this one, I'm gonna look and I'm gonna say the last bit is 3, so that's gonna be my leaf. That means that everything else has to be the stem. My stem would be 12, and my leaf would be 3. And then I make sure that down in the key, down below, where I explain how the stem and leaf plot works, I say 12, 3 equals 123. For our decimals, you can break it at the decimal, or you can still break the last part. So, for example, if I wanted to break it at the decimal, I could say 2 and then 35, and I could say whenever I have 2/35, that means 2.35. All right, I hope this helped, and I hope to see you again soon. Bye.